Hey, what's up, guys? Welcome to the stream. Starting a little bit late tonight. To be honest, I'm feeling a little bit under the weather, so I'm not sure how long I'm going to last, but I did want to take a little stab at this multidimensional array stuff. Oh, hey, Brahim. How's it going? Yeah, not feeling 100%, so yeah, I don't know how well I'm going to do tonight, but thought I'd give it a shot. Because I've been thinking about all this multidimensional array stuff and looking at it. And actually I was thinking a lot more about just the way I've been implementing my whole parser for this for the stabs stuff. And the more I work on it, the more I think that this regex approach that I'm using may not be the best strategy. Even though the format is a little bit weird, there is some regularity to it, and it might actually make more sense to implement like a more standard parser to try to define some kind of grammar or something like that, and basically tokenize the stab strings and try to like make sense of it based on tokens and have more of like a state machine type of thing. It's going to be more complicated in some ways, but in another way, a lot more flexible. And you know, I like basically starting off with regex matches made a lot of sense at the beginning when I just wanted to match a few types. But as I keep adding and adding more, what I'm noticing is there's a lot of similarities between all my matchers. Sometimes, you know, the differences are very small. They can just be like one character. You can sort of see there's a lot of similarity. And it's going to continue that way because really there is some sort of regularity to it. And yeah, so that's it. I'm thinking maybe I'm going to have to change strategies eventually. But anyway, sticking with what I have now. Like, okay, so let me just like back up a bit here. So for arrays, which I worked on the last stream, what we have is we have this kind of type definition. So let's say here I have an array called C, and there are 6 elements in an array of ints. So over here you can see what the stab looks like for that. Now the key there is, so you got your usual here, this is the variable C. It is of type 25, and the fact that there's an equal means we're going to actually define the type here. It is of type array, so that's what the A is for. Now the R, I thought AR meant array, but actually it turns out A means array, and then R means that we're going to now define the range of the we're now going to define the range of, or saying like basically it's an array that is made up of range 26. Now what is range 26? It's equal to, now once again, the weirdness of this type is of this stabs info is it's saying range 26 is defined as range 26, so it's in terms of itself, where its lower bound is 0 and its upper bound is -1, and then that semicolon closes that bit. Okay, so what does this mean? It's saying our index is of some type that has basically the 0 to max int range, or max whatever value you want to set for this. To be honest, it doesn't really matter. This is completely innocuous and useless information, and so I already ignore this, but it does show up. Now if we were to ignore this and we continue, we have then basically the information about this array. So there's always a 0 or nil, so like a don't care value. 5 here is the upper bound of the array. So that's, you know, this is 6. It means that we can index up to 5. And then finally, the last value here is the type that this is an array of. And in this case, it's of type 7. And I know 7 is int. It's up here. See, int is of type 7. So this makes sense. And now D is also an array of ints, but this time it's an array of 7 elements and not 6. And that's why D here actually defines a brand new type. And here you can see, because the very first time we defined an array, it defined the type of its index, R26, to be equal to this, like I said, useless piece of information. From now on, since all indices are of the same type, it no longer defines this range 26. It no longer has the equals after it. So this here basically disappears, and then the rest looks like this, okay? So here it's saying, once again, D is of type 27, which is equal to an array whose indices are a range of type 26. There's our nil value. That's the upper bound, so 6 is the max value you can index with. And it is also of type 7, which is integer. Very nice. Now we have E here. So E is a 2-dimensional array of 8 arrays of 9 integer elements. Okay, so that's how you think about this, right? So E is an array of what? Well, it's an array of 8 of what? Of int 9s, you know, of like, it's basically an array of 8 elements where each element is an array of 9 ints. So how is this then defined in terms of stabs? Basically it says, all right, I've got our E here. It is of type 28, which is a brand new type. Type 28 is equal to an array. Its indices are of type range 26. Nil value, upper bound is 7, so that's here. So this is talking about the inner part here. And then it says, and it is of type 29, which is a type we haven't seen yet, but 29 is a new type, equal to, once again, an array. Again, its indices of type R26, nil value. This guy has an upper bound of 8. So now we're talking about this, right? We're defining this array here, and it is itself of type integer. So there you can see the multi-dimensional aspect here at play, right? So the thing that you can see that is common is it sort of looks like this. Or I guess I should put like this. So let's see here, equals to, yeah, exactly. No, actually I should go all the way until the 29. So this section here, right, defines the first array type, and then the next here defines the second array type. And of course, if you have third dimension, then this 7 here would have an equals after it. So like this. So now actually writing a regular expression matcher for this is non-trivial because it's recursively defined. It's not easy to do this. So I'm basically going to have to do something similar to what I had to do for structs, which is do like sub-regex matches to expand the last element. So for example, what I'm going to end up capturing here is, when I try to capture this whole line, is I'm going to capture E, and I'm going to match portions, but then the last part here, which would normally be, let's say, the type, well, my type will be equal to all of this, or potentially even more than that for 3 dimensions. So yeah, it's going to be a bit of a challenge here. I'm not, and this is why I was saying that it probably doesn't make sense to use regular expressions. So here I was actually messing around with exactly this example. Oh, and actually before I get there, I want to also note that what's interesting here is 29 here defines this outer array like of 9 ints, right? So just for fun, I also declared here G, which is an array of 9 ints. And you can see that in the stabs info for G, it actually says G is of type 29. So there you have this type 29 here. So there is like a logic to this, you know what I mean? And so my job is going to be parsing correctly our multi-dimensional arrays into multiple types. And then after that, everything should just sort of fall into place. So my big challenge really is just parsing, you know. If I were to add, so let's say we replace this with H here, make G here, and go with like 10, 11, and 12. All right, so we got F. Let's see here. Oh yeah, okay. So for G, once again, you can see like the sort of the repetition here for the array types. So you've got this here, and then 31 now defines a new type. And 31 is itself equal to an array that ends in 32, where 32 now is a new type that is over here. And it's interesting, right? Like if I say H is 11, 12, like this, I expect then that H should be of type 31, right? Which would be the type over here defined by this here. So let's see if that's true. Yeah, so you see, H is of type 31. 31 is basically this portion of that is being defined by up here. So that makes sense. Now, can I write a good matcher for this using regular expressions? I'm not sure. I keep wondering if there's a way to do this. Yeah, like it would be nice if I could extract these parts, but I'm not sure. Let's see. Yeah, let me try something here. If I were to just have this, so we've got this portion. And let me just remove that just to start. So we've always got basically an identifier equals to AR. Then we have a number. Yeah. And then we have, so yeah, this is the part where I just sort of ignore that range information. So technically I could even remove that. Well, it's nice. It's not really hurting here, but let me just remove it to simplify. Okay, so followed by something here, which is this even being? Hold on a sec. Right. No, okay, not quite. What's going on here? Right, okay, global, don't return after first match. Otherwise it would do that. This tool, yeah. So yeah, regex is one of those things where it's, you know, there's that joke about you have a problem, so you decide to use regex, and now you have two problems, and it's a joke because it's funny because it's true. It is really powerful and can really get you out of a yeah, it can really get you out of a jam sometimes, or it can make things simpler at first, but it gets really quickly into a unwieldy kind of what the hell is this, did this regex mean kind of territory. It has its limitations for sure. And this tool, I mean, this tool is amazing. Definitely recommend it. It's really cool how it supports all kinds of flavors of regex. It's got these different options here. It gives you the match info with color coding. I can't recommend it enough for anyone who's trying to do anything with this kind of thing. But yeah, that's basically the idea. All right, because I don't care about that number. But actually, I do care. No, I don't care about it. That's right. That's why I didn't have it there. And then I didn't care about the 0 either. But the first digit I cared about was the 9, followed by the 31. So this actually almost does it. 26. Let me see here. And then I end up with one final digit at the end, and that's a problem. So just give me a second. Yeah, so I'm also trying to remember, I think the regex matcher that I'm using would not return, it does not work like the way this one works with the global. It'll probably just return one match, and in order to do it this way, I would need to use the iterator method in C++ for iterating over multiple matches in a given string. So there's that. So what's this here? Why does group 3 look empty? What am I missing here? So group 1 gives me 30. Group 2 gives me 9. But then this here shouldn't be from 12 to 12. Third capturing group. Why is this not? So let's see. First one should be that. Equals AR something, and then 0, and then we capture the second value, semicolon, and we should capture the third. Okay, oh, I see it. And it's the problem is that there is more stuff that comes after. Is that what it is? Yeah. But if I were to wrap this up like that, so now I would get, because I'm saying there may be more than one of these whole matches. So now the 9 is showing up, the 10 here is showing up. Let's see. now. Yeah, I don't, okay, because it doesn't know how to end this matcher. I see. So what if I told it that to match one or more numbers? Would that work? Instead of being, it still doesn't know. It doesn't know what to end it on. Okay, that's the problem. Yeah. I see. Yeah, regex is hard. See, I would have thought that if I wrapped, like, if I wrapped this before the equal sign and after that, and say one or more, wouldn't it be able to see that it should stop here and start matching this one here as a repetition? This is where my regex knowledge starts to fall. See, like, it doesn't do what I expect. I mean, I guess alternatively, what I could do is, what if I were to break this up? Like, could I do this a different way? That's what I'm wondering. Like, match, okay, I know that I've matched an array line. Just like what I did for structs, I ended up like doing like this kind of sub-matcher. Let me see, how did I do structs again? I called it the value match, which was a, oh yeah, that was my multi-match thing. Yeah, this is the thing where I use an iterator. So yeah, it would have to be something like this. Would I be able to define now a sub-match like that would actually work? This one was not so bad because of the semicolon at the end. I don't have such a luxury though. It's too bad. Too bad they didn't put a semicolon in there. But yeah, that's because it basically equals to another type. Semicolon here, semicolon there, semicolon there. So for each member, they always end with a semicolon. It's because it's not a recursive definition like this one is. So maybe I would, instead of doing it that way, I could do some kind of split. So say I know we've got an array. If I were to grab out right, but that eats up the equals. Or Aha. So that works. Oh, that's interesting. Oh no, that doesn't work. I was fooled. Let's see, or foiled. Let's see, could I do this? I always get this wrong. Okay, because it stops in the last. It matches up until it greedily matches until the last equal or end of line, but it doesn't match the inner one. Okay, I have an idea. Let me try something. Let me say like I just so what if we just play this stupid and we say we're just gonna look for something like this, like that. All right. Just a reminder, did I actually commit this? I did, eh? Yeah. Before I embark on replacing everything, just want to make sure I did this correctly, like that I'm not throwing away good work here. All right, so let's say I did this. This just simply matches, or should, if I did it properly. What's the problem? Oh, right. Okay. So basically we'll just write like a really dumb matcher that just matches the whole thing. It just tells us that it's an array. But then we got to do something similar, but not using regex to split the inside, or at least not using it for splitting it, because I can't easily. What I can do, I think, is do something like so we split so the entire actually, do I want to split the entire string? I guess I could at least get the first part. Yeah, that would make sense. Right. Okay, so var name will still remain the same. These ones will disappear for now. So match of 2 is our basically type definition, if you will, that may have more than one. So we take that and we split it on equals. So if I do that, then what we're talking about here is got our variable. Oh yeah. Oh yeah, and we're not matching that. Maybe, okay, actually no, I need to at least match everything after this. Like this. So group 1 is the variable, group 2 then becomes this guy here. Yeah, that makes more sense. Slowly but surely, right? So let's say we're given this. 1 will be C, and 2 yeah, actually I need the 30. I do need that, don't I? Let me think here. So okay, so does this make sense? Let me see. Would I want 30 here? And then this? So then when we split that, it would look like this. 3 parts that look like this. Part 1. So we prime it at least with that guy. So group 2 actually gives us the type ref, or the type definition number for the first array. And then we may have 1 or more parts to define. All right. Just trying to think. Say I do it this way, then what I would need to say is I could ask for each dimension of the array we can always assume, of course, the 0th one. Now, if there's more than one, so 30 would be the type definition for the first array, whose type then ends with 31, and then 31 is actually defined as this one here. Because the other way of doing this would be to put the 30 in here, but then, yeah, can't quite do that. Yeah, I think this is the way to do it. Okay, so what would this look like? We would want something like yeah, I'm actually thinking, why even bother keeping it as strings at this point? Let's just try like this. So the first one would be our match of 2. Followed by, no, that's it. In the first part here, I need to extract info here. So if dimensions is empty, we start off with the type def ID from match of 2, so that would be like 30 over here. And really, what we care about right now is this 9 here, so that would be what, 0, 1, 2, the second element of this guy. I guess I can't emplace because I don't have a constructor. Okay, if it's not empty, then what we do is we access the, oh, I do actually need an index here. All right. Okay, so now we access part of I minus 1. Oh, right, but I've lost my, I lost this value. Okay, this is what we'll do. Okay, let me see if this makes sense. Okay, so the first time this will be equal to, say, 30. Then we start going through there. We grab this guy. We split it on the semicolon. So 0, 1, 2. So we say add a dimension where for 30 and with 9. So 30 comma 9. And then we say the next ID will be 31. Now, in the case of only 1 here, we're going to end up putting 7 into next ID, but we're not going to actually use it. So we need to know the type, and that's what's missing here. We have the type definition ID for this dimension, but we don't have the type that it refers to here. So yeah, there should be, that needs to be in there. Okay. So maybe I could simplify this further. Turn off my notifications here. All right, let me think. So we have the type definition for the current one, and we need to know the type that it refers to. So in that case, then what we can do so the type definition will be 30, and then we need to set, okay, yeah. Maybe I'll keep them in the same order because it's just confusing. Let's do that. Does this make sense? So now we do this, 30. We move the max index into there, and we actually move the type reference ID into there, which actually means I guess I don't want to move it then. Okay, so what we'll do instead what? So first, our dimension uses otherwise, and I guess I should really not call this ID. I'll call it type def ID, so just it's really clear because we have ref and def. First dimensions type. Not type, first dimensions def ID is matched to, otherwise it's the type ref ID of the previous dimension. All right, so if I did this right, I will have parsed out every dimension and their types correctly. So this is actually a bit of a straying away a little bit from the way I've done other matchers, but that's okay. That's sort of the good thing about having abstracted matching, is that it doesn't have to be regular expression. It's just a thing that takes a string and gives us back the info we need, right? So that's good. And actually, at that point, I may as well just return this vector. It's there. So I'll make it private there, or at least make this private. Okay, so let's just see if this even does the thing. Yeah, so I kind of broke what I write here for parsing prefix the var name and the colon to be able to match the type. That's true. Oh yeah, I may have broken support for, let's see. That's annoying. The type string. Will this work? Yeah, actually this should work. Shouldn't change anything. Let me just double check. If this were in star, let's say. yeah, so we end up with the last type here equal to, so let me just grab all this and see if our matcher will do what we expect. So first we get this, which is fine, and then we just split, and yeah, I think this will work as well. So that should be okay. I think. Oh yeah, because I called it the type ref ID in the last one. But it won't be so much a type. That's why I'd called it the lsim type. So, but that's only ever going to happen for the very last one. Okay, let's just see what this looks like. Let me just remove all this. Right. Okay. Oh, built-in VA list. So this guy somehow matched. That's not right. That means that it's not restrictive enough. Well, that's kind of surprising because I've got the AR in there. How did this get in here? Oh, right. Yeah, okay. Basically, okay. Yeah, that's not good. What we need to do is only do this kind of stuff if we actually did match. Not super elegant. I mean, probably what I should do is make dims lazily create this stuff, just in case we don't care about it. But whatever. All right. Okay, so here's our actual first case. So C:25 is an array 26. Oh yeah, and I removed the part that ignores the R26. So that's not good. Didn't I? Yes, I did. That's just annoying. Yeah, so this one's going to fail for sure. Let's see. Yeah, this is all garbage. Right. How do I handle that part? that's right. I can't split on equals with this guy in the way. It seems so simple too. I suppose, I don't know if I should like assume that won't be there. Or assume it'll only be defined once, type of the index. Let me see something. Okay, wait a minute. Maybe I can use my multi-matcher here. Since I only want to match up to there, I was splitting on equals, so I think I can do that this way. Instead of doing a split on equals, I already have something for extracting parts. So let me take a look. Actually, let me just borrow what I already wrote here. So it's basically this. Something like this. Back here, how do I eat up this last one? This is a pain in the ass. Right, so that would capture if it's only a number though. I need the whole token. See how terrible this format is? Or maybe I'm just using the wrong tool for this. Yeah. Yeah, I can't even split. I just realized I can't even split on the equals, even if I were to remove that section. Well, you know what? I think I'm not going to figure this out tonight. I'm a bit tired and I'm not really seeing what the right move is here. I think I'm gonna sleep on this, think a little bit more about it, and maybe come up with a better solution for parsing these crazy stabs formats. So, guys, I'm gonna stop here. Should be back next week on Tuesday. So thanks for watching, and I'll see you next time.